So let's go ahead and get started talking about the metric system, which is a system of measurements that we will be using in any science class. And in particular, we always use in chemistry. The metric system is a system of measurements, and it's used by actually most of the world. It's exclusively used in the scientific community. And one of the reasons why we exclusively use it in the scientific community is because remember that science is a study of the everyday world. But one of the most important parts about science is being able to communicate that information and to spread that information. So, when we want to be able to communicate this information to different people and people from different countries that speak different languages, we need to somehow have a common language that we all speak. And so, one of the most important things is having a unit or a system of measurement that is universal. Now, this unit of measurements has what are called base units, and you can also add prefixes. And adding a prefix to that number changes the scale of that number by a factor of 10. So let's go ahead and let's look at first our most common bases. So here are our most common bases when we are thinking about different units of measurement. For example, our base unit for mass is going to be grams, and that is seen with a lowercase g. For volume, we use the unit liter, and that is represented by an uppercase L. For length, we use meters, that is represented by a lowercase m. For time, we use seconds, which is a lowercase s, something that we're actually already fairly familiar with because this is, again, a unit that gets used by everyone across the world, whether you are using our US system of measurement or you're using the metric system. And then we also have temperature, and temperature is usually used with this unit of a Kelvin. We will also be using the unit Celsius a lot in chemistry. And we will see in another video that there is an easy way to convert between Kelvin and Celsius. So let's get kind of a working understanding of how big some of these units are. So for example, 1 gram is approximately 0.0022 pounds. So a gram is fairly small when we think about it in relationship to pounds. You can think of it as being the size of about a small paper clip. So if you were to weigh a small paper clip, it would be approximately 1 gram. In the United States, we are actually fairly familiar with the unit liter. So when you go to the store and you purchase a 2-liter bottle of soda, that is 2 liters. You will often sometimes see a liter as well. If you think about a gallon of milk is approximately 3.8 liters. A meter is very similar to a yard. A meter is 3.3 feet, while a yard is exactly 3 feet. If you think about the height of a doorknob on a door, regulation, they are usually about 1 meter from the floor. You can also think about this as a lap around the track is 400 meters. Now let's go ahead and look at our bases. So our bases are things that we can add to the front of one of those base units to change the size of a unit by a factor of 10. If we think about this right here, this would be where we have a unit without a prefix in front of it. Now we can make the number bigger by a factor of 10, 100, 1,000, 100,000, and so on and so on. So you can see that we can easily start making these numbers a lot bigger by adding a prefix in front of it. So we get something like a decagram, a hectoliter, or a kilometer. We also could have something like a megaliter, or you might be familiar with this one, a giga. We often use this when we talk about computers. We could have a gigabyte, which has to do with the amount of memory, or we could have a terabyte, which, as you can see, is 1,000 times larger than a gigabyte. Now, we can also go ahead and we can also make our numbers a lot smaller. And this becomes really helpful in chemistry Because a lot of the times when we're thinking about things like atoms, we are talking about things that are really small. So we need to be able to have units that can read things that are really small. So, for example, picometer and nanometers are usually used to talk about the size of the atoms. We will see later on that there's actually a special unit called an angstrom that is often used to talk about how large an atom is. So we can use the prefix deci to be 10 times smaller, centi to be 100 times smaller, milli to be 1,000, micro, nano, and pico. So you can see that we can add these in front to change how small the number actually is. Now, sometimes these can be confusing to memorize or be confusing to kind of recall how big they are or where they are in the hierarchy. And you can see that there is a mnemonic that is sometimes used in order to identify or to kind of remember the order. So the great mighty King Hector died unexpectedly drinking chocolate milk Monday night. And I think it's funny because usually I don't see pictures, but you see that we have night pictures on here. So that's just kind of an easy way to be able to memorize the order in which these actually are. Now let's go ahead and take this into some more practical uses, and let's compare this idea of 100 meters to 100 kilometers. Now notice that I said meters, and the first thing that we want to recognize is that this M does represent meters. There is no prefix in front of it, so it's not changed or anything, it's just the base unit. And we're comparing it to kilometers, and again, the prefix of K is a kilo. And then here we have meters again, so this is meters. And what I would do is if we think about these two units, I know that a kilometer is larger. And if I want to think about how many times larger, it is 1,000 times larger than a meter. So when we're comparing these two units, I know that 100 kilometers is 1,000 times longer or 1,000 times further than 100 meters. And again, just noting that prefix in front. Let's look at one more. Here we are comparing 7 mgs to 7 gs. Now again, I know that my base is always second, so this is grams. And I want to think about what the m is. And you also want to note that this is a lowercase m. There's also uppercase m's when we are thinking about our prefixes. So this is actually a milligram. And here, of course, is just a gram. Now I know that a milli is making this number smaller, and I just want to think about how many times smaller. And when we look back at our sheet, or if we look at that table, we see that it is 1,000 times smaller. So if we're comparing our 7 milligrams to 7 grams, what I am saying is that whatever was weighed, because this is a mass, a unit of mass, so mass was taken, this is 1,000 times smaller or lighter a 1,000 times smaller than whatever was 7 grams. So we can see that just by adding that prefix in front of my base unit, we change the scale of the number. Hope this video was helpful and hope to see you again soon.